Okay, let's look at 2.3.2 dependent sample. So we are still in the topic of confidence interval to population, mean mu1 and mu2. But now this one is dependent cases. Okay, for the dependent cases, how you want to know that what is dependent cases? Okay, this subtopic consider estimation procedure for the mean difference of two dependent samples. Sometimes we call it as paired data. Okay, mu d, where the d is the difference between two data set. Okay, how you want to know that that one is dependent sample? So confidence interval for the dependent sample, we call it as mu capital D. Okay, how you want to know the sample is dependent? First, the sample must came from the same subject. Okay, and sometimes it has before and after data, and it has similar sample size. So this case we call it as dependent sample. Okay, for example, one person here, so I want to estimate the confidence interval for this person this person weight loss, so after diet program. So I want to know what is the difference between the weight loss difference for the diet program. So from the same person, we have the data before the diet program and we have the data after diet program. So for example, before diet program is 60 kilogram, after diet program is 50 kilogram. So these two sample is dependent because it came from the same object. Alright. So if dependent sample, we call it as paired data. Okay, so you will have mu capital D, where the D is difference between data, x1 minus x2. Okay, so what are the formula to construct confidence interval paired data? Okay, first you have to consider, is there any sigma square given? If sigma square given, straight away use formula number 1. If sigma square is not given, you have to consider the sample size. If sample size greater than 30, use the second formula. If sample size less than 30, use the third formula. Okay, so that you notice here you have the capital D, right? So capital D is the difference between two data. So you have capital D between two data, you also will have mu capital D, and then you also have the SD. Okay, so don't worry, we will look at the example and the exercise how to construct confidence interval for dependent sample. Alright, example 2.8, dependent cases. A tire manufacturer wishes to compare the made trade wear of tires between the new and conventional material, so new and old material. One tire of each type is placed on each front wheel of each of 10 front wheel drive vehicles. Okay, the choice as to which type of tires goes on the right wheel and which goes on the left is made with the flip of a coin. Each car is drive for 40,000 kilometers and then the tires are removed and the depth of the tread is measured. The result will as follows. So you have this result of the depth of tread. How many cars? For 10 cars. So one car, new material, old material, and you have the D. Calculate 90% confidence interval for the population mean difference in the tread wires. Alright. So now here, how you want to know this one is dependent cases. So if you read the question, it said that the new and old materials. So it said that in one vehicle, they place one tire, the front wheel with the new material and the second tire with the old material. So with the same vehicle. Okay, so because of the data new and old material came from the same vehicle, so it is a dependent cases, or this one is paired data. Okay, so in paired data, mu capital D, you have to find the D, where D is the difference between two data. So now here the D is given to you. Right? So how they get the D? How they get 0.16? How you want to know new minus old or old minus new? So if you read the question, it said that between new and old. So new minus old. 4.35 minus 4.19, you will get 0.16. 5 minus 4.62, you will get 0.38, and so on until 4.7 minus 4.5, you will get 0.2. Okay, so from the D here, D is your new data. So from your D here, you can calculate X bar D. Why X bar? Because this is sample. So calculate X bar D and calculate SD. So how to calculate X bar D and SD? Use your knowledge how to find X bar and S. So from this example, your X bar D is equals to 0.2320 and your SD is equals to 0.1826. Okay, use this D new data. Use this D new data to get the X bar D and the SD. So now you have the N, you have the X bar D, and you have the SD. So you want to construct confidence interval for the mu D. So let's look at the formula. Which formula you want to use? Can you use the first formula? You only have N, X bar D and the SD. Can you use the first formula? Cannot, because you don't have the sigma D. Okay, now can you use formula number 2? So let's look at our N. N is only 10. So can we use formula number 2? Cannot, because our N is 10. So we have to use the third formula. So the formula is X bar D plus minus T alpha over 2 nu SD over square root N. Okay, let's check one by one. Do we get the X bar D? Yes, here. Do we get the SD? Here. Do we get the N? N is 10 here. Okay, so now we don't have this one. Okay, confidence level is 90%. So alpha is 0.1. So alpha over 2, 0.05. Okay, so the nu is N minus 1. N is 10 minus 1 equals to 9. So T 0.05, nu is 9, is equals to 1.8331. So now you get all the values, substitute into the formula. Okay, substitute into the formula here. You will get confidence interval. X bar D is 0.2320. 0.2320 plus minus 1.8331 times SD is 0.1826 divided by square root 10. Okay, then you substitute into your calculator and come up with the answer. So my answer lower boundary is 0.1262 and the upper boundary is 0.3378, and we have the unit centimeter. And lastly, don't forget to interpret. You will have here, we are 90% confident that the population mean difference in trade wear between new and old materials. So you copy from that. Lies between 0.1262 and 0.3378 centimeter. Okay, so the keyword here is you have to know this question is dependent sample. Okay, so because of dependent sample, choose your formula to construct the confidence interval. Okay, let's try to do the exercise. So you can try it first and compare with mine. So adding computerized medical image to a database promise to provide a great resources for physicians. However, there are other methods of obtaining such information. So the issue of efficiency of access needs to be investigated. An experiment was conducted in which 8 computer proficient medical professionals were timed in seconds both while retrieving an image from a library of slides and while retrieving the same image from computer database with a web front end, and the data given as follows. So it talks about the images, okay, and then they put the first one retrieving image from a library of slides. So the first one is slide and the other one image from a computer database. Okay, so from the same computer they put image slides and the other one is digital. Assuming that the time retrieving the image is normally distributed, find the 95% confidence interval for the true mean difference between slide retrieval time and digital retrieval time. Okay, so how you want to know this question is dependent. Okay, so how you want to know this question is dependent. So it came from the same subject. Alright, so a computer using slides and digital, and then they time the retrieval time. Okay, so from the same computer, then this is the same subject, and then the first one that you need to know is you have to find the D. So the D is slide retrieval time and digital retrieval time. Slide minus digital, so slide minus digital. So 30 minus 25, you will get 5. 35 minus 16, you will get 19. 40 minus 15, you will get 25. And then 25 minus 15 is 10. 20 minus 10 is 10. 30 minus 20 is 10. 35 minus 17 is 18. 62 minus 16 is 46. Okay. So another keyword for dependent is stated here both while retrieving image from slide and from computer database. So slide and digital is running both from the same computer. So this one is the dependent sample, come from the same subject. So you have the D, and number 2, you have to find the X bar D. Substitute this data into your calculator and come up with the X bar D. So the X bar D here is 17.8750 and the SD is equals to 13.0651. Okay, you have the X bar D, you have the SD, and you have the N. N is equals to 8. So which formula you want to use? You cannot use the first formula, also cannot use the second formula. So the formula you have to use is the third formula. So the third formula, you have to find the T alpha over 2 nu. So now our confidence level is 95%, alpha is 0.05. So alpha over 2, 0.025. Nu is 8 minus 1 equals to 7. T 0.025, nu is 7, is equals to 2.3646. Okay, substitute all into your formula. Confidence interval x bar d is 17.8750 plus minus 2.3646 times the SD 13.0651 divided by square root of 8. Okay, you will get the answer is lower boundary 6.9524 and the upper boundary is 28.7976 seconds. So don't forget to interpret. We are 95%. That the true mean difference between slide and digital lies between 6.9524 and 28.7976 seconds. Alright, the second exercise for dependent cases. A sample of 38 lorries, diesel lorries, will run for both hot and cold engines. So the same lorry, they run for the hot and cold engine. Okay, so the hot and cold engine came from the same lorry. So a paired data. So this one is dependent. A study is conducted to estimate the difference in fuel economy. The mean difference of fuel mileage between hot and cold engine is 0.250 liter per kilometer, and the sample variance of the difference is 0.013 liter per kilometer. Assume that the fuel mileage is normally distributed. Find 98% confidence interval for the population mean difference of fuel mileage between hot and cold engine. So now if you notice here, they just give you 0.250. So what is the notation for 0.250? For this question, they didn't give you data, but they just give you the values. So if you notice, the mean difference, so mean difference is x bar capital D. Right, and the sample variance is SD. Okay, mean difference is x bar D. Okay, so our n is 38. So here is 38, and then you have x bar D, and then you have the SD. So which formula you want to use? Can we use the first formula? Cannot, because we don't have the sigma. Can we use the second formula? Yes, can, because our n is 38. N is greater than 30. So use the second formula. So the second formula is x bar D plus minus z alpha over 2 SD over square root n. So now let's substitute all the values. You have the x bar D, yes. You have the SD, yes. You have the n, yes. You don't have this one. So confidence level 98%, alpha is 0.02. So alpha over 2 is 0.01. Z 0.01 is equals to 2.3263. 2.3263. Okay, now substitute all. Confidence interval is x bar d 0.250 plus minus, sorry, I will put it here. I'll put here. Zero point 250 plus minus 2.63 times ST. ST is 0.013 over square root of 38. Okay, substitute all into the formula. Okay, so we didn't notice here. Here is sample variance. So this one is S squared D. Okay, so because of that you have to square root this one. So you will get 0.2070 and then 0.2930 liter per kilometer. And then don't forget to interpret. Do it yourself.